Okay, we should be on slide number 9 in our notes. Today we're talking about something called the mean value theorem. But before we start in the mean value theorem, I want to review the concept called the intermediate value theorem. And this is a topic that we discussed quite a while ago, but it leads us right into the mean value theorem. So go ahead and write this down in your the margins of your packet or something. So the intermediate value theorem says that if f of x is continuous on the closed interval a to b, and w is between f of a and f of b, then there exists at least one c on the interval a to b such that f of c equals w. So you might recall this as I read it off, but you might not remember the exact result. So if we draw a picture that kind of matches what we're told here, we start off with a and b on the x-axis, and then f of a and f of b on the y-axis. All right, so first of all, if f is continuous on the closed interval a to b, that means we have an endpoint at a and an endpoint at b, and we continue from the endpoint to endpoint without picking up our pen. So this is the most basic picture that we can draw. Now, if I draw this picture, all right, then I read along. It says, and w is between f of a and f of b. So there's some w here. Now, w really just refers to any y value in between f of a and f of b. Then there must exist a c in between a and b such that f of c equals w, meaning an x value of c leads you to a y value of w. Okay. Now, the basic result here is that if you have a continuous function, then you must pass through every y value in between f of a and f of b. This was the intermediate value theorem. So you have seen this before. I just want to make sure we review that. Now, the intermediate value theorem leads us right into the mean value theorem. So let's read the mean value theorem. Nothing to write down here, but we'll draw a picture that involves this. So it says if y equals f of x is continuous at every point on the closed interval a to b, just like the intermediate value theorem, and differentiable at every point of its interior a to b, then there is at least one point c in a to b at which f prime of c equals f of b minus f of a over b minus a. So you really do want to put like a circle around this because this is the result of the mean value theorem, which is rather important. All right, so let's draw a picture. All right, just like earlier, okay, we have a to b, we have f of a and f of b. All right, so once again, endpoint at a, endpoint at b. Okay, now the first part said it was continuous on the closed interval a to b. So that means we must have an endpoint and an endpoint, and we draw without picking up our pen. Okay? But the next part is that it is differentiable at every point of its interior, meaning when you go from one point to the other, it must be a smooth curve, right? So no corner points, cusps, no asymptotes, no jumps, anything like that, right? So the easiest picture, now please don't draw this just yet. I will tell you when I want you to draw this curve. So first of all, could we have a curve that looks like this, just like the last one? Yes, that is both continuous and differentiable. Okay? Could we have a curve that looks like that? And the answer is yes. That is continuous and differentiable. Remember, it has a nice smooth curve. All right? But could we have a picture that looks like that? And the answer is no. This is continuous, so it would qualify for the intermediate value theorem, but it is not differentiable, so it does not qualify for the mean value theorem. So we don't want that. Could we have something that looks like this? And the answer is yes. It is smooth. It doesn't matter how many kind of, relative minimums or maximums it has, right? I mean, it could look something like like this, as long as it is smooth, right? Meaning it cannot look like this, right? It cannot have any corner points, cusps, anything like that. So this would not be allowed. All right? Now, what about something like this? This is smooth, right? And sometimes people get a little confused. They say, yes, it's smooth, so it's continuous and differentiable. But the fact is that it is not a function, right? It fails the vertical line test. So that would not be one that we can have. All right, so anyway, the easiest picture that I draw is something like this. It's a nice curve that's smooth and kind of just goes from one to the other, but it is a curve. I don't draw just the line, right? And I'll show you why. Because the result of the mean value theorem, well, is that there is one C, at least one point, in A to B. So that means that C is somewhere in between A and B, right? And it says f prime of C. So what does f prime of C mean? Well, if you look at our graph, f prime of C would refer to the slope of the tangent line. So if I draw in this tangent line at C, f prime of C refers to the slope of that tangent line. So the slope of the tangent, f prime of C, is equal to f of B minus f of A over B minus A. Now, you might remember that that is actually the slope of the secant line, or also known as the average rate of change. So if I look at these 2 points, these endpoints, and I connect them with a line, that is actually the secant line. So f of B minus f of A over B minus A, that refers to the slope of that secant line. And the slope of the tangent line, well, if those are equal, then what does that mean? That means that those lines are parallel. Now, the result of the mean value theorem says that the slope of the tangent line at some point must be equal to the slope of the secant line. Or we could also say that the instantaneous rate of change is equal to the average rate of change. Now remember, instantaneous, that refers to at a single point. So what the mean value theorem says is there must be at least one single point on this interval where the derivative, or the instantaneous rate of change, is equal to the average rate of change over the interval. Okay? Now, a nice illustration of this is an example. Okay, so let's say that I am driving to St. Louis. Let's say it's a 300-mile trip. All right, now let's say that it takes me about 6 hours to get there. So what does that mean? That means that it takes me, or it's about a 50 miles per hour trip for me. Now remember, 50 miles per hour, that is the average speed that I travel, correct? But the mean value theorem guarantees that at least at one point in time, I must have been traveling at exactly 50 miles per hour, right? I mean, if that makes sense, if you think about it, if it took me on average 50 miles per hour, then I must have been at some points traveling faster than 50 miles per hour, and at other points traveling slower than 50 miles per hour. But the mean value theorem guarantees that I must have been traveling at exactly 50 miles per hour at least one time. All right, so that is the mean value theorem. So it's very important that you remember the result, f prime of C equals f of B minus f of A over B minus A. And actually, you really do want to try to memorize the whole thing, because the mean value theorem is a theorem that will be referred to by name on the AP test. So it's absolutely essential that you have it memorized, because you will see it a number of times on the AP test. All right, so let's go ahead and